Welcome to chapter 14 and 15 on acids and bases, where the only question you are asked, not totally, but mostly, is what is the pH? So this is a map of chapter 14 and 15 and all the different ways and all the different types of questions and mixtures of acids and bases where we can ask the question, what is the pH? And we need to solve each one of them a different way. So you need to look at this and start classifying things. You need to understand it's incredibly important to classify every chemical you have as a strong or weak acid or base. Because the type of problem, how to solve the pH depends on the chemical you have and what type of mixture it's in with other chemicals. You can see there are a lot of different options here. So let's go through chapter 14 and figure out all the different tools and how we're going to use them. First thing we're going to study is acids. You can have a strong acid all by itself. You're going to really appreciate any of these that have strong acids and strong bases in them. They're going to make life a little bit easier. But we have strong acids that can be all by themselves, solve the pH, and a weak acid all by itself, solve the pH. I can have mixtures of strong acids. Now notice I wrote mixtures here, and these are and signs, not plus signs. And this is just a good reminder for chemistry. Just because you mix two chemicals together in a beaker does not mean you get a chemical reaction. Acids will not react with acids. So I have two acids. How is that going to affect the pH? Two bases in a mixture. How does that affect the pH? I can have bases over there. Two strong acids. I can have a strong acid and a weak acid. How would that affect the pH? And then I can have two weak acids. Now, obviously, you need to be very good at the ones that are all by themselves, the strong and weak acids and bases, because once you start mixing them together, it gets a lot more complicated. So you need to have these number 1, 2, 6, and 7 like perfect so that you can work through the rest with a little bit of ease. Then we can do bases. And we can have a strong base all by itself. And it's important to remember here, when we do the acids, we have pHs, hydrogens, Kas. Anytime we're working with the base equations, we have hydroxides, POHs, and KBs. So we need to mind our A's and B's. Okay, not your P's and Q's, your A's and B's. So a POH we can get with a strong base all by itself. Convert that to pH. Then what do we do if we have a weak base all by itself? What's the balanced equation that goes with this? All of these have reactions that go with them. I can have a mixture of two strong bases. I can have a mixture of a strong base and a weak base, and a weak base and a weak base. And you can kind of see some analogs here as we compare acids and bases. So if you get half of them, there's a pattern over here. You just have to do the base equivalent of the exact same math. This just gives you a framework to start thinking about it and putting it in. After that, still in chapter 14, we will handle polyprotic acids, acids that have more than one hydrogen in them. You have one strong acid that does this, H2SO4, so we'll look out for that, and then a myriad of weak ones. So what is that going to do to the pH? And then we have conjugate salts, because every weak acid and base is going to have a conjugate acid and base that is possible to make also. Recognizing these conjugates for what they are and what their pH qualities are is going to be very important. And then how do you set up that math? How do you solve for a pH? So conjugates are very important. And then 1, 2, 6, and 7. These are, I would say, those are the 5 big tools that you're just going to use over and over again. So conjugates is where we're going to end chapter 14, but it's incredibly important in the next chapter, and it's a big part of acids and bases. Okay. With any of these mixtures, you could have volume changes, so you might need to watch out for that. But in general, this is the format of chapter 14. Then we're going to continue on and keep asking that question in chapter 15. So 15 is mapped out on the board here as well, but it's all the same tools. So the first thing we say is, how do we calculate the pH of a buffer system? And that is when you have an acid-base conjugate pair in the same container. Instead of just an acid making a conjugate or having a conjugate by itself, we have them both together in the same container. So how is that going to affect the pH? And then we can get all sorts of neutralization reactions where we can mix strong acids and strong bases together, strong acids and weak bases, weak acids and strong bases, and weak acids and weak bases. These are actual chemical reactions. These are just mixtures of different chemicals that we would solve the pH for, but now I'm actually getting some chemistry. Anytime you mix an acid and a base together in the same container, unless it's a conjugate pair, that's a mixture. If you're mixing these together, they're going to react, and that's going to be a limiting reactant problem because they go to completion. K values are so big, they go to completion. So this is a limiting reactant problem. And this is where chapter 15 gets really hard. Not only do you need to know the net ionic equation for all four of these types of reactions, not only do you need to watch out for volume changes and do the stoichiometry to figure out your limiting reactant, but depending on what your limiting reactant is, and then what you have left over as a product, which of the chemicals you have left over, you're going to have to do something else to solve the pH. For example, all of these have some of them have strong acids and bases in them. If you have a strong acid and base left over, you might solve it with one of these solutions over here. When you finish, you might have a weak base all by itself. So you'd have to do a weak base problem. You might have a weak acid all by itself. You would have to do a weak acid problem. It's possible for you to get a buffer at the end, and you'd have to do a buffer problem. Strong acids and bases, it's possible to just have water at the end. So really, all of these tools that you're learning in chapter 14, you have to be very good with them, because in chapter 15, once we start doing this chemistry here, these are titration neutralization reactions. We go through our stoichiometry with limiting reactants, and then you're going to have to say, after my stoichiometry, what do I have left, and which of these tools do I need to use to solve these four pH problems? Chapter 15 is a monster of a chapter because it relies on you having almost perfect knowledge of chapter 14. And you can see chapter 14 is hard enough up here. And every one of these scenarios up on the board right here answers this same fundamental question: what's the pH? So careful classification of your chemicals and having a large framework to start to work these things into is going to be essential for you to do well in chapters 14 and 15.